So we're going to revisit x and y intercepts, which we looked at a little bit before. We're going to be looking at reading it from graphs, but also from tables. So when we're looking at x and y intercepts from a graph or a table, the x-intercept is where it crosses the x-axis. Now, a really nice thing to notice is they always have a y-coordinate of 0. Second case, the y-intercept is where the graph crosses the y-axis, and it always has an x-coordinate of 0. So let's look at some examples here. Here is our y-axis, so this is our y-coordinate. So you could write the y-intercept, or I like to write y-int for short, is 2. Now, if I wanted to write that as a coordinate, which is super helpful, the x value of that coordinate is 0, because remember, we said y-intercepts have an x-coordinate of 0, and the y-coordinate would be 2. Now, this here is where it crosses the x-axis, so this is called the x-intercept, or x-int for short. The value of the x-axis, the value on the x-axis here is 3, but if I wanted to write that as a coordinate, x would be equal to 3 and y would be equal to 0, because we said x-intercepts have a y-coordinate of 0. So let's look at a couple more examples. Here's our y-intercept here, so y-int. That is -1, and as a coordinate it would be 0 minus 1. Now we appear to have a half value here for this x-intercept, so that would be, you could write 1.5, or you could write 1.5, or you could even do it as an improper fraction and write 3/2 if you wanted. And if we were to write that as a coordinate, I think I'll just keep the decimal form. I'd write that as 1.5 for the x-coordinate and 0 for the y-coordinate. Okay, so that's not too bad. We need to be careful when we're looking at tables. So we need to find the y-coordinate has an x value of 0. So this is the y-intercept. Sorry, I think I misspoke before. The y-intercept has an x-coordinate of 0. There we go. So the y-intercept, you could either write that as the value of y minus 2, or I like to write it as a point, 0 minus 2. The x-coordinate is going to have a y, sorry, I did it again. The x-intercept is going to have a y-coordinate of 0. So the x-intercept here, we could either write that as 2 or as a point, 2, 0. Oh, now the next one is pretty interesting. I'm looking for my y-intercept where x is 0, and for my x-intercept where y is 0. But I notice the zeros are both together here. So that actually means that the y-intercept is 0, because that's the value of y when x equals 0. But it also means that the x-intercept is 0, because the value of x, the value of the x-intercept, is when y equals 0. So it looks like it crosses the graph at the same point, and that's actually the origin. So the coordinate of either of these points is the origin, which is 0, 0, which I really enjoy writing that as a point because it looks like a little owl. Okay, I'd like you to have a go at finding the y-intercept and the x-intercept for the next table. Pause, and then you can watch me go through the explanation. Have you paused? Hope so. Okay, this is the y-intercept. Reason is, that's where x is 0. So we could write that as 8, or the coordinate would be 0, 8. And where is that x-intercept? All the way over here. The x-int, or the x-intercept, is 4, and written as a point, 4, 0. So that's pretty handy. Now, we actually will have instances where we want to calculate the x-intercept. Now, we can't just read that directly from the graph. So we're going to be substituting in y equals 0 into our rule, also known as the equation, to find the x-intercept. Now, we'll come back to this little sticky note in a future lesson. It does note that the x-intercept cannot be read directly from this graph, and we'll talk more about that when we talk about what M and C represent. So for now, we're going to be substituting y equals 0 into our equation every time we want to find the x-intercept. So let's do that. So first off, we have our first rule is y equals x minus 7. So we're going to sub in y equals 0. So that means we're going to have, every place we have y, we're replacing it with 0, so 0 equals x minus 7. You'll notice we have an equation to solve. Let's put the x minus 7 first, then the 0. We'll add 7 to both sides, so x will be equal to 7. So that means the x-intercept is 7, or written as a point, as I like to do. We have 7 for x, and like we said, we substituted in y equals 0, so that's our second point in our intercept. So we'll do the same thing here. We're going to sub in y equals 0. So 0 is going to equal 2x plus 5. So let's rewrite that. 2x plus 5 equals 0. We'll subtract 5 from both sides. So 2x is going to be minus 5. Then we'll divide both sides by 2. X is going to be minus 5 over 2. Or you could write that as minus 2.5. So as a coordinate, we're going to have minus 2.5, or you could have minus 5 over 2. Now remember, we had that y value that matched up with this of 0. So let's pop that there. And let's have a go with the next two. So again, we sub in y equals 0 for x int. So I'm just reminding myself that I'm finding the x-intercept here. So we're going to have 0 equals minus x minus 2. So minus x minus 2 is equal to 0. We add 2 to both sides. Minus x will be 2. And we need to get x all by itself. We can't have minus x. So you can either divide or multiply by negative 1, which will give you x equals negative 2. So our coordinate here is minus 2, the x value we just found. And remember, we had that y value of 0. I like to imagine that I'm dragging it down from there and putting it in my point. Okay, last one. Sub in y equals 0 for x int. Oh, this one's kind of nice. We've got 2x plus 3 times, instead of y, we've got 3 times 0 equals 24. That 3 times 0 delightfully goes away. So we're going to have 2x equals 24. And when we'll divide by 2, x is going to be 12. So our point here is 12, 0. Again, that 0 coming from that y, that 12 coming from that x. Nice. Now that we know how to find the x-intercept, we can also find the y-intercept. And in doing so, if we know the x-intercept for a graph and the y-intercept for a graph, well, we can draw the graph, because the minimum number of points needed to draw or plot a linear graph is 2. If you just have 1, you don't know where you're drawing your line, but with 2 points, you can draw a line between them. So, the x-intercept, we subbed in y equals 0. The strategy we use for the y-intercept is we're going to sub in x equals 0. And we'll talk about a shortcut for some styles of equation rules later on. So remember, when we sketch graphs in maths, that's not the same as sketching in art. So we're not going to do lovely feathered lines. There's going to be neat ruled lines. We're not going to be using lovely sketching as you might refer to in art. It means something a little bit different in maths. Art sketching is lovely, just different meaning in maths. Now we need to, we talked about the fact that we had neat ruled lines. What else do we need to do? So we don't want, so no, whoops, I just misspelled that, scratchy, artistic lines. I think we've repeated that, but that's okay. And as always, we use a pencil. Remember, don't use a erasable pen on a test because it can actually disappear. So we don't want this. When we're sketching, we're going to be using our ruler, so I'll have that ready to go. Hope you do too. And we'll have our pencil. So to do this, I like to set up 2 headings to do this style of question, and I recommend you do something similar. You might even like to put a little line in between. So seeing as we're using our ruler, I might as well get that out. So I'm going to put a little line in the middle of my working out here. There we go. So first off, let's find the x-intercept. So we'll write x-int. And as a reminder to ourselves, to find the x-intercept, we did a bunch of examples of that before. We sub y equals 0 into the rule. So I really enjoy writing a heading for myself because it means I remember what I'm doing, and also it tells my teacher what I'm doing. So our rule for this one, y equals minus 2x minus 4. So instead of y, we're going to substitute in 0. So we can have 0 equals minus 2x minus 4. Now we're going to solve that. Minus 2x minus 4 is going to equal 0. We'll add 4 to both sides, so minus 2x will be equal to positive 4. And dividing by negative 2, x is going to be 4 divided by negative 2 is negative 2. Now let's write that as a point. So the x-int is negative 2, that's this value here, and the y value that matched up with that was 0. So that's our first point. Now let's do this process, but instead of finding an x-intercept, we're going to now find the y-intercept. And to do so, it's very similar, but instead we sub we sub x equals 0. Now, if you're feeling confused about why we're substituting in y equals 0 to find the x-intercept like before, and now when we're substituting in x equals 0 to find the y-intercept, I encourage you to go back when we talked about what all y-intercepts had in common. That was always an x-coordinate of 0, and what all x-intercepts had in common. They had a y-coordinate of 0. So that's why we substitute that value into our rule to find that point. Okay, so instead of y equals minus 2x, we're going to write minus 2 times 0 minus 4. Oh, love it when things are multiplied by 0. So y is just equal to minus 4 here. So the y-int, that was a bit easier to find. The y-int is going to be 0, because that's this x value, and minus 4, that's this y value. So now we have 2 points. We have our x-intercept here, negative 2, 0. So let's get our pencil and let's plot that point. So negative 2, 0, that's on the x-axis, has a y-coordinate of 0 and x-coordinate of negative 2. So our x-intercept is here. Now our y-intercept is a separate point. The y-intercept is on the y-axis, and it has a coordinate of 0, minus 4. Oh, I think my voice is going to go. Let's see if I can make it through. Okay, so now that we've got our x and our y intercept, we can draw a line going through them. And because I'm about to lose my voice, I'm going to leave it there. Have a go at the next couple of questions. Have a good day. Bye-bye.